Welcome back to The Explainer. We spent a lot of time taking critical data, examiner reports, and course syllabus structures and transforming them into visual masterclasses for you. Today, we are laser-focused on Cambridge computer science. Whether you're navigating IGCSEs with codes 0417, 0478, 0983, 0984, or O-Level 2210, right up to AS and A-Level 9618, the core challenge remains exactly the same. We are going to look at your exam strategy today, not just as a set of random questions you have to survive, but as an architectural blueprint. I want you to think of designing your answers like a master architect building an absolute structural masterpiece. Every single paragraph, every line of code, and every single validation method needs to serve a distinct structural purpose. Let me paint a picture for you. We see two types of students all the time. Let's call them Alex and Sam. Alex is the type who just overloads the paper with raw computer science facts, right? Just a massive brain dump with absolutely zero analysis. And then you have Sam. Sam rushes, Sam completely misses the command word requirements, and just writes whatever comes to mind first. Today, we are going to fix both of those approaches. Grab your notebooks, let's get building. 15%. I really want to hook you right out of the gate with this massive insight derived straight from the examiner data. Data validation methods, and specifically range checks, account for roughly 15% of the total marks in your Paper 2 exam. I want you to stop and really think about what 15% means in the grand scheme of your final grade. Think about it. That is absolutely not just a passing comment in the syllabus. That is literally the entire difference between two full grade boundaries. It is the difference between an A and a C. It's huge. If you're sitting there overlooking the deep theoretical foundations and the technical methodologies of range checks, you are leaving a massive, inexcusable chunk of your grade entirely up to chance. You're basically walking into the exam room and handing your marks back to the examiner. We are not going to let that happen. All right, let's look at our agenda for today. First up, the 15% secret. Second, we'll dive into the top 3 examiner warnings. Third, the procedural framework. And finally, reaching top-tier marks. Let's get right into it. Section 1. The 15% secret. Okay, let's establish our baseline right here. A range check is a data validation method ensuring that inputted data falls within predefined acceptable upper and lower boundaries. Sounds simple, right? But pay very close attention here. The source material issues a massive examiner alert on this exact topic. Principal examiner reports reveal that candidates consistently, and I mean constantly, confuse key terminology. You might know exactly how to code a range check in your sleep, but if you're in the exam and you mix up a range check with a length check or a type check in your written explanation, you are going to lose those marks. It happens to the best of us under pressure. You must always define these terms clearly before you start using them in your extended responses. Anchor your answer with this crystal clear definition first, and then, only then, do you build your logic on top of it.
So, the absolutely crucial point here is how these marks are actually awarded by the examiners. Let's look at the method mark strategy. Look, examiners do not just glance at your final compiled solution and give you a simple pass or fail. That's not how it works. Academic benchmarks for the syllabus require logical, structured reasoning. Marks are awarded for clear working and logical decomposition. This means if you are writing out an algorithm for a range check, the examiner is actively rewarding your analytical process. They want to see the step-by-step breakdown. If your final code has a minor syntax error, maybe you missed a semicolon or bracket, but your logical decomposition and your working are crystal clear, you can still secure the majority of the marks through this methodical approach. This is where the PEL framework comes in. Point, evidence, explanation, link. Top students structure their answers this way to guarantee method marks. Now, before we continue and look at the biggest mistakes students make, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2. The top 3 examiner warnings. Let's see where things go wrong.
This brilliantly illustrates why so many students miss out on top grades. They focus on the end product rather than the process itself. Here we are pulling back the curtain on the principal examiner reports to see exactly where thousands of candidates are just bleeding marks. These are the 3 exact reasons candidates fail when implementing range checks. Mistake 1, confusing cause and effect in data validation. Remember Alex from earlier, the student who just dumps facts? Alex often states what the code does, but completely fails to explain the effect on the system if invalid data actually gets through. Mistake 2, forgetting boundary conditions and edge cases. Remember Sam? Sam rushes. If your acceptable range is 1 to 100, checking the number 50 is super easy. But examiners report that rushing students consistently forget to check the absolute limits, the edge cases like 0, 1, 100, and 101. Mistake 3. Answers lack specific question context. If the exam asks you about validating a temperature sensor in a smart greenhouse, and you just give a generic textbook answer about validating random numbers, you get 0 marks for application. Your answer has to be anchored to the specific scenario they gave you. So, here is your definitive checklist to counter those exact mistakes. First, differentiate cause versus effect clearly. Second, always test your upper limit edge cases. Third, always test your lower limit edge cases. And fourth, anchor your logic to the provided scenario. I want to issue an interactive challenge to you right now. Think back to your very last past paper attempt. Seriously, visualize it. Did you spot these flaws in your own answers? Did you actually test those boundary conditions, or did you just test a safe middle number and move on? Next time you see a sample paragraph, I want you to immediately scan it and find the flaw. Look for the sentence that is losing marks because it lacks context or forgets the boundary.
Section 3. The procedural framework. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, now that we know exactly what the examiners are hunting for and the traps they meticulously set, let's shift to the solution. The theoretical foundations of Cambridge computer science draw on systematic analysis. This isn't about guessing, it's about following a rigorous, highly repeatable protocol. This procedural framework is your ultimate blueprint for algorithmic thinking. I want you to memorize this 5-step sequence. Step 1. Identify key elements. Ask yourself, what is the data type? What are the specific boundaries? Step 2. Apply relevant principles. Which validation method is actually required? In our case today, it's a range check. Step 3. Execute analysis with clear working. This is where you write out your step-by-step logic, showing your method to grab those method marks. Step 4. Verify results. This means testing thoroughly, hitting every single one of those edge cases we just talked about. And finally, Step 5. Present in appropriate format. Does the command word ask for pseudocode, a flowchart, or an extended written response? Systematically processing your answer through these 5 distinct steps guarantees you are hitting those required cognitive domains of knowledge, application, and analysis every single time. Let's move on and see how this builds into practical application. Algorithmic thinking in data validation requires step-by-step decomposition to ensure appropriate data structure selection and efficient code implementation. You cannot, I repeat, you cannot just slap a range check onto poorly structured data and hope for the best. This practical application develops your core programming skills. You design algorithms, you implement solutions, and most importantly, you test them rigorously. Rigorous testing at every single stage of this decomposition is what proves to the examiner that your code isn't just a theoretical guess. It is a functional, robust, and reliable solution. If you're given 60 seconds to scan a complex data table in an exam, this decomposition is what allows you to extract the core trend immediately without panicking. Section 4. Reaching top-tier marks. Let's elevate this. Everything we have discussed so far will definitely get you a solid passing grade. But if you want to push into the highest grade boundaries, securing those top-tier marks requires a fundamental shift in how you approach the paper entirely. You have to move away from basic algorithm design and elevate your response to advanced critical and evaluative analysis. Now, what's really interesting about this slide is the stark contrast between 2 types of students. On the left, we have standard code execution. This student writes the pseudocode for a range check perfectly and moves on. They get the application marks. Great. But on the right, we have evaluative critical analysis. This is the elite response. This student doesn't just write the code, they justify their decisions with solid evidence. They analyze the trade-offs of their chosen algorithm, they discuss space and time complexity, and they openly acknowledge the limitations of their validation method. The sources explicitly state that top-scoring candidates consistently demonstrate this evaluative thinking. It's the ultimate transformation from a basic answer to an architectural masterpiece. Let's break down exactly what the examiner means by evaluative thinking. To get the highest possible marks, you need to consider multiple solutions. Tell the examiner why you chose a range check and not just a presence check.
Analyze structural trade-offs. Identify time complexity. How fast does your algorithm actually run when it's processing massive real-world data sets? Identify space complexity. Is your validation routine taking up unnecessary system memory? And finally, evaluate edge case performance. Does your algorithm completely break when it encounters unexpected boundary data? Considering these factors is the ultimate differentiator. It proves to the person marking your paper that you aren't just memorizing syntax from a textbook. You are thinking like a genuine professional computer scientist.
To help you cement this all into your brain permanently, I have an interactive challenge for you. Can you create a mnemonic using the first letters of our 5-step procedural framework? IAEVP. That's identify, apply, execute, verify, present. Maybe something like intelligent algorithms ensure valid programs? I want you to come up with your own right now. Seriously, make it weird, make it funny, make it memorable. Having this mnemonic locked in your head will be your ultimate safety net when that inevitable exam panic sets in. It forces you to slow down, take a breath, and follow the exact systematic sequence the examiners are desperately looking for.
Let's recap all of our core takeaways into 3 golden rules for your final exam strategy. First, decode command words. Understand exactly what cognitive domain is being tested before you write a single word. Second, apply the Peel and procedural framework. Identify, apply, execute, verify, present to systematically build your answer point by point, explaining and linking your logic clearly. And third, contextualize verification. Never forget those boundary conditions and always anchor your testing to the specific scenario provided in the paper. Now listen closely. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
I will leave you with this final provocative thought. In your next exam, when you inevitably encounter that 15% question on range checks, will you panic and just lay random facts down like scattered bricks? Or will you use the procedural framework, hit every cognitive domain, and build a structural masterpiece that examiners absolutely cannot help but award top marks to? The choice and the strategy is entirely yours. Keep practicing those past papers, keep analyzing those tricky edge cases, and we will see you in the next explainer.